Hello, geometry. Here we go with lesson 5. So how many congruent parts do we need to prove that triangles are congruent? Hopefully you've been paying attention in the last 3 lessons and you know that it's 3. Now, how many parts are congruent in congruent triangles? Go back to the first lesson. We talked about how there's 6 parts congruent. So there's a difference there. We need 3, but there's 6. This is your big idea right here. Therefore, if we can prove 2 triangles are congruent with only 3 parts, and there are a total of 6 parts congruent, then that means that the remaining 3 parts are also congruent by the definition of congruent triangles. So this is the big idea. Now we're going to shorten it down. You saw the title of the lesson was Cpctc. What that stands for, it's an acronym that stands for corresponding parts of congruent triangles are congruent. Okay. On Math Excel, you'll see it Cpctc. They use literally every word that's in there. So they mean the same thing. Cpctc and that mean the same thing. It's just easier to say Cpctc. What that says is if I can show that the triangles are congruent, then I can say any of the other 3 parts that I didn't show are also congruent. Okay. I know it's probably a little confusing right now. But Cpctc says if 2 triangles are congruent, then all of their corresponding parts are also congruent. So, example here is, first thing I want you to see is right here. We're proving something a little differently now. Everything up till now has been prove the 2 triangles are congruent, prove the 2 triangles are congruent. Now I'm saying prove that 2 sides are congruent, or maybe 2 angles, or something like that. What are we trying to prove? Okay, we're trying to prove sides are congruent. How is this different than what we've done so far? I just said that we're not proving the triangles are congruent, or are we? All right. Why is triangle KLJ congruent to triangle OMN? Well, you should know the shortcuts by now. Hopefully you see that this one's side angle side. So the 2 triangles are congruent. Now, because they're congruent, aren't all the pieces of the triangle also congruent? Think back to lesson 1. We just proved that those are congruent. And I can write that angle K is congruent to angle O, angle L is congruent to angle M, angle J is congruent to angle N. We did that back in lesson 1. We can also say KL is congruent to OM, LJ is congruent to MN, and KJ is congruent to ON. All right. So what we can say then is JK, if you look at it, JK is congruent to NO because of the congruent statement. Or an easier way of saying it is Cpctc. All right. One of the big ideas, Cpctc is only used after. Huge idea here. You prove the 2 triangles are congruent. Why do you have to use it after? Well, think about it. I'll go back up to what it stands for. Corresponding parts of congruent triangles. I have to prove they're congruent before I can use that definition. That's why Cpctc is used after you prove triangles are congruent. Please pay attention as we go through this. Okay. Again, we're trying to prove 2 sides are congruent here. To fill in the blank proof, AB is congruent to EB. How do I know that? Well, that's given. What else is given? Angle C is congruent to angle D. The vertical angles theorem now is my third statement. I'm going to say angle ABC is congruent to angle EBD. So that's 3 things, right? 1, 2, 3. I'm going to go ahead and mark the last one there. So why are the 2 triangles congruent, right? We're proving CAB, triangle CAB is congruent to triangle DEB. Why? Angle, angle, side. Up until now, this is where we stopped. This would be a really easy proof if we just stopped right there. But now I'm going one step further. Now I look at my congruent statement, which I've just proven. AC is congruent to ED because of Cpctc, right? After I've proven the triangle's congruent. After. All right. Pretty simple one here. I mean, when I say simple, it's a difficulty level of probably 2. All right. Again, what are we trying to prove here? That's the key thing I want you to see. Well, let's start with the givens. MO is congruent to RE. That's given. And ME is congruent to RO. Again, that's given. You could have done it in one step. I did it in 2. Doesn't really matter. I'm going to go ahead and make sure you see that that's 1 and 2. Hopefully you're noticing that we're still doing the same stuff we've been doing. It's just now we have an added step at the end. Hopefully you see that OE is congruent. Now you do have to think about this one. M to O is the same as R to E. So when I go O to E on the other triangle, I'm going E to O. All right. I'm not too picky about this, but while we're learning it, I want to show it to you the right way first. So OE is congruent to EO because of the reflexive property. Now I can say the triangles are congruent. Triangle MOE is congruent to triangle REO. Why? Well, make sure you're still getting this. This is marked. It's the third thing. This is side, side, side. Now I want to say that angle M is congruent to angle R. What allows me to say that? Well, I just proved that the 2 triangles are congruent, so that means that the corresponding parts are congruent. So I get Cpctc, all right? And that's how you use Cpctc in a normal proof, all right? I'm going to clear it. Scroll down and do the next one, another fill in the blank proof. Now, there are other ways to use Cpctc, and these proofs are tougher. I'm not going to sugarcoat it here. The first way, and there's going to be 2 main ways here. There are others, but I'll show you the 2 most common. We're trying to prove that ML is parallel to JK. Parallel, not congruent. Cpctc only proves that 2 things are congruent. So how do we use this? Well, let's just go through the proof. First part's pretty easy. JM is congruent to LK, that's given. JK is congruent to LM, again, that's given. MK is congruent to KM, that's reflexive, very similar to the previous proof that we just did. And now I have enough to say that the triangles are congruent by side, 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 right? Now, if we want to show that ML is parallel to JK, how are we going to do that? How are we going to show 2 things are parallel? This takes you back to Unit 3, Lesson 2. If we can show corresponding angles or alternate interior angles are congruent, then we can say that the lines are parallel. Well, if we're trying to show LM and KJ, we need to show these 2 angles right here. Well, aren't those 2 angles congruent? JKM, that's this one, and LMK, that's this one, are congruent, right? Look at the congruent statement. JKM, JKM. So start in the middle, go to K, go to M, LMK. Those are congruent by Cpctc. Notice where Cpctc falls. It almost always comes right after you prove the triangles are congruent. Now, since those angles are congruent, I can say that those two lines are parallel because of the converse of the alternate interior angles theorem. Okay. I know that's tricky. I will ask you to be doing that. I don't know if I'll put it on a test, but you should understand where that's coming from. Does Cpctc always come as the last step in the proof? Hopefully you saw that. No, it does not. Does Cpctc directly prove lines are parallel? No, it doesn't. It doesn't prove lines are parallel. It proves angles are congruent, which then you can use to say lines are parallel. Another way of using it is to prove a segment is an angle bisector. How? Let's do this one. All right. Given. I got a couple givens. Back to typing here. I've got SI is congruent to SO. All right. I also have P as the midpoint of IO. That's given, but what does that mean? It's not a congruent yet. I need to. What does that mean? It means that those two things are equal. I need to write that now. PI is congruent to PO, the definition of midpoint. And that would be my second piece. Now I need a third piece. Hopefully you see the reflexive here. Go ahead and type it now. SP is congruent to SP by the reflexive property. Now I can say that triangle SPI is congruent to triangle SPO. Why? Side, side, side. Again, everything up till now, we've been working on for almost a week and a half or so. Now it's the new part. I want to show that PS bisects that. I can't just say that as my next step. I can't say PS bisects ISO by Cpctc. It doesn't do that. Only thing Cpctc says is that two things are congruent. That's all I can say. Well, what two things being congruent would help me show that PS bisects this angle? So if it bisects that angle, that means that this angle and this angle have to be congruent. These two angles would have to be congruent. Do we have the information to make that happen? Yes, we do. So angle ISP is congruent to angle OSP. Why are those congruent? Cpctc. Then, since those two angles are congruent, I can say PS bisects angle ISO by the definition of angle bisector. Okay. The third way, I'm not going to do a proof for this one, is to prove a point is the midpoint of a segment. Okay. These are not the only other things Cpctc can be helpful in proving, but these are the most common ones you will see. Again, the big idea is using Cpctc. Most of your proofs are going to stop right there at step 6, but just wanted to show you that it can go further. All right, that's the end of this unit, or sorry, the end of this lesson. We still have 2 lessons left in this unit.